Hey guys, this is Mrs. Harbin, and this is Algebra 1. We are starting Unit 7, which is all about systems of equations. And today we're going to look at how to solve these systems of equations by graphing. Before we get started looking at our new information, let's take a quick second just to review what we've already learned about graphing inequalities and graphing equations. So first, go ahead and graph this expression on a number line. X is greater than negative 2. Now remember that a number line is nothing more than just the x-axis. We've got our origin here, and we want to show that x is greater than negative 2. And let me switch my pen on here. All right, and in order to do that, we are going to locate negative 2. If it were equal to negative 2, we'd put a solid colored dot there, but it says it's greater than negative 2. So we're going to do an open circle. And then because it's greater, we're going to show that all values going to the right are greater than negative 2 using that solid arrow there. All right, let's try another review. Graph the expression on a number line. The absolute value of x equals 4. Now hopefully you remember that for absolute value there are two possible answers. There are two numbers whose absolute value is equal to 4. Because it does say equal, we are going to put solid dots. So let's locate the two numbers whose absolute value is 4. And hopefully, if you were doing this on your own and trying to work along with me, you marked negative 4 and positive 4. Those are the two numbers whose absolute value is 4. Let's talk about linear equations. Remember that linear equations have an x and a y variable, and that when we graph them, they form a line. That is why they are called linear. If we take a look at that word linear, you see that it's got line right in it. All right, we have an x and a y, both of those to the first power. And in order to graph linear equations, well, the easiest way to graph linear equations is to solve for y. So when we solve this equation for y, we get y equals negative x plus 5. That 5 is our y-intercept, or our starting point. So we would go up 1, 2, 3, 4, 5. That's 1 point. And then the number in front of the x is our slope. In this case, it's a negative 1 slope. So down 1, left 1. Down 1, left 1. Nope. Down 1, right 1. Down 1, right 1. If we write negative 1 as a fraction, we've got negative 1 over 1. So down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And then after we get several points in a row, we can use our straight edge, and we can connect that line. We'll do that here in just a second. For our second equation, to solve for y, again, I'm going to subtract x from both sides so I can get the y term by itself. That gives me negative 3y equals negative x minus 3. And then we divide everything by negative 3. So that gives me a y. Negative x divided by negative 3 is positive x over 3, or 1x over 3, 1/3 x. And then negative 3 divided by negative 3, anything divided by itself is 1. All right, so again, my 1 is my y-intercept, my starting point. And my slope is 1 over 3. So that means I would go up 1 and to the right 3, and up 1 to the right 3. When I get several points in a row, we'll connect those dots. And let's go ahead and graph those two lines here. So there's our first line, y equals negative x plus 5. And here comes our second line, y equals 1/3 x plus 1. And we can see that these two lines do have a point of intersection. They've got one coordinate in common. And if we had to label that coordinate, we would say that it is 3 over on the x-axis and 2 up on the y-axis. So that point of intersection is 3, 2. It's the one point they have in common. All right, taking a look at these two lines then, we've already identified the point of intersection. We look at the one point where they intersect, and we write our answer as a coordinate since they intersect at a coordinate. And we just said that these two lines intersect at 3, 2. All right, so let's get started with our objective for today. The objective for today is that you, the student, will solve systems of linear equations by the graphing method. So first, we're going to define what systems of equations are, and then we're going to look at how to solve these using graphing. Let's start with our definition. A system of linear equations is made up of two or more linear equations. Seems simple enough, right? System just means we have more than one of something. And then linear equations, those are our y equals mx plus b. So we've got a y variable, an x variable, and some numbers in there. So when we have two or more, we call that a system of equations. Any ordered pair that makes all of the equations true is a solution to the system. So let's start off by checking some ordered pairs and seeing if they are solutions to the system. Remember that if something is a solution, it makes a true statement. So let's take a look at our first system of linear equations. It's a system because we have two, and linear equations because they both have x and y variables. And we want to check and see if the point 11, 2 is a solution to the system. That means, does it make this one true? And does it make this one true? So everywhere we see an x, we're going to plug in 11. And everywhere we see a y, we're going to plug in a 2. So let's check our first equation. So we get x minus y, or 11 minus 2 equals 9. And over here on the right, we plug in 11 for x, so 2 times 11 plus 2 equals 9. We're now going to simplify those and see if they produce true statements. So on the left, 11 minus 2 simplifies to 9, and so we get 9 equals 9. That is a true statement. On the right, we have 2 times 11 is 22. 22 plus 2 is 24. We get 24 equals 9, and that is not a true statement. So 11, 2 was a solution for the first one. It was not a solution for the second one. Therefore, it is not a solution for the system. In order to be a solution for the system, it has to be true for both or all parts of the system. All right, let's try another one. Here are your two equations. Again, x minus y equals 9 and 2x plus y equals 9, but this time we want to check the point 6, negative 3. So pause the video right here, and on your own, plug in 6 for x and negative 3 for y. Make sure you use parentheses when you substitute so you can protect that negative here. And see if this is true for both equations. If this is a solution for both equations, then it is a solution for the whole system. Okay, hopefully you paused. Now let's check your work. When we plug in 6 and negative 3 in the first equation, we get 6 minus, and then we've used parentheses to protect our negative 3. So 6 minus negative 3. And over here, 2 times 6 plus, and then again we've used parentheses to protect our negative, negative 3 equals 9. When we simplify that, 6 minus negative 3 is the same thing as 6 plus 3. So we get 9 equals 9. And over here, we get 12 plus negative 3, which is 12 minus 3. And when we simplify that, 12 minus 3 is 9, and we get 9 equals 9. So it was true for the first equation and for the second equation. Because it's true for both equations in the system, it is a solution for the whole system. 6, negative 3 is a solution. So when we're testing to see if a point is a solution for a system, our procedure is, or our steps, first, we're going to substitute it into both equations. Second, we're going to simplify to see if it makes true statements. Third, if it makes true statements for all the equations, it's a solution for this whole system. But if it doesn't make all of the linear equations true, if it doesn't make true statements, then it is not a solution for the system. It must be true for every equation to be a solution for the whole system. So hopefully you guys heard those steps and you wrote those steps down when testing a point to see if it's a solution. If you missed those steps, go back and listen and write those steps down again. All right, now we said today we were going to solve a system by graphing, and so far we haven't done any graphing. So far we've just plugged and chugged to see if a solution is true. So that's what we do when we're given the solution. But a lot of times we're not given the solution. We're just given the equations and we have to find the solution. And we're going to do that today by graphing. So let's take a look at our steps. So to solve a system of equations by graphing, first, both graph both equations on the same coordinate plane. Remember that to graph an equation, you're going to write it in y equals mx plus b format. B is your intercept or your starting point, and m is your slope. You'll use those two things to get yourself several points on the graph before you connect your points with a straight line, with a straight edge. So first, graph both of your equations on the same coordinate plane. If you've got 2 equations, you should have 2 different lines. If you've got 3 equations, you'd have 3 different lines. If you had 4 equations, you'd have 4 different lines, so forth and so on. So graph both equations on the same coordinate plane. After that, step 2, identify the solution. On a graph, the solution is the coordinates of the point of intersection. So if you have one line going this way and one line going this way, your solution is this one point where they intersect. It's the coordinates of that point. That will give you your x and your y value that will work for both equations. Step 3, you'll check the solution by substituting it into each equation. So after we graph, we make sure that we graphed it correctly by plugging and chugging. Okay, those were our 3 steps for solving a system by graphing. If you didn't write those steps, go back a little bit in the video, pause, and make sure you have those 3 steps written down. Let's take a look at some examples here. All right, so we're given this system of equations. Y equals negative x minus 2. We need to identify our slope, and we know our slope is negative 1, and our y-intercept is negative 2, or 0, negative 2. Our second equation in our system is y equals x minus 4. Our slope is going to be 1, and our y-intercept, or our starting point, will be y equals negative 4, or 0, negative 4. All right, we're going to use that information to do step 1, and step 1 is graph each equation. So let's take that information over here to the Cartesian plane. All right, line 1 started at 0, negative 2, right here. And then we had a slope of negative 1. So down 1, right 1, down 1, right 1, down 1, right 1. We're going to put several points on the graph here. And then we're going to use a straight edge to connect our points. Now we're going to graph the second equation, which was y equals x minus 4. First, we start with our y-intercept. That's our starting point of negative 4 down here. And then our slope is 1, which means up 1, right 1, up 1, right 1, up 1, right 1. We're going to graph several points there and then use a straight edge to connect our lines. After we have both lines graphed, step 2 is to find the point of intersection. Here is our point of intersection. We're going to label that point of intersection with its coordinate points. And the points for that point, or the coordinate points, is 1, negative 3. That means our solution to this system is x equals 1 and y equals negative 3. If we go back and we plug those in, which was step 3, plug in and check, we get negative 3 equals negative 1 minus 2, or negative 3 equals negative 3. That is true. That's a solution. So it worked for the first one. Let's check the second one. Negative 3 equals 1 minus 4, which is negative 3 equals negative 3. All right, that's a solution. So we checked our work to make sure it is a solution for both equations. So step 1, graph the equations. Step 2, find the point of intersection. Step 3, plug and chug to check. All right, solution was 1, negative 3. We did all 3 steps. Nice job. Let's try this last one. We're going to solve the system by graphing. X minus y equals negative 5 and y equals x plus 5. First, we would rewrite both equations for y. So we would need to solve that equation for y so that we can identify the slope. Okay, so we've got the slope is 1 and our intercept is 0, 5. Sorry, this is just our first equation. Our second equation, 3x plus y equals negative 7. When we solve for y, we get y equals negative 3x plus 7. Our slope is negative 3, and our intercept is negative 7. When we go to complete those steps, we're going to graph both equations. So here's our first equation. And then we go to graph our second equation. Here's our second equation. We then find our point of intersection, which in this graph is negative 3, 2. And last but not least, we would plug and chug to check our work. And when we plug that in, you should get 2 true statements. So our solution is negative 3, 2. All right, guys, see you in class.